if you wanted to do every 5 pixels, we can do something like if x mod 5 equals 0. Yeah, so we have like a striped pattern. Oh yeah, perfect. So now our particle is moving across the screen. Wonder what happens if we make it go faster. So let's do like 50 and 4. Seems to still hold up. Okay. All right, so here's where we ended off last video. We basically figured out how to render pixels to the screen. And what I have here is a double for loop that is going through the pixels in the x direction up to 640 and in the y direction up to 800. So that's the full height of the window. And for every one of these pixels, we're going to draw a red pixel. So that's why we have half the screen is red and half is blank, because we're only going up to half the width. So our total window is 1280, so half of that is 640. So that's why only half of the window is red. So I also just thought maybe we can make some cool patterns with selecting different pixels to be drawn as different colors. So for example, I think if we do something like, if we wanted to do every 5 pixels, we can do something like if x mod 5 equals 0. Then we can draw a pixel. Let's just make it blue for fun. And we can see what that looks like. Yeah, so we have like a striped pattern because every 5th column will be painted blue in this case. Not sure if you guys can see that, so maybe I'll make it like every 15 pixels. Yeah, nice. Cool. Okay, so for today, I think maybe I can do a better explanation of the update and game loop later on. And I think I want to do a very simple like physics simulation. So let me think about where to get started. I think we can clear this out. And we can, actually, you know what? Let me make a new project file. I'll be right back. All right, so I made a new, basically blank project. This is just boilerplate code to get us a window. I got rid of the unnecessary functions we were calling the last project, and I'm creating now an 800 by 800 pixel wide window. The title of the window should be called Particles, and we have our standard game loop here, and then I'm going to just render the text particles. So this is a function. These are all functions from Raylib pretty much, and this draw text function is allows us to render whatever text we put pass into the constructor. So we're going to render particles. These are the X and Y positions of where we want the text to be. This is the font size, and this is the color. And all of this is from, I'm just checking the cheat sheet here on the website. I think the text function is down here somewhere. Yeah, our text module. So I'm using this void draw text function, and it tells you the inputs to it here. So the text, position, font size, and color. So that's the end of our draw loop, and then that's pretty much the whole program. So if I run it, then we should see, yep, we see exactly what we have put into the draw loop. Okay, so now I think we can, let's work on trying to render basically a particle. So I think what we probably want to do is figure out how to draw a circle. So again, I'm going to look through this cheat sheet and figure out if there is a circle function. So it's probably under shapes, and we have draw pixel. Okay, so draw circle is over here, and it's going to take in the X and Y coordinates of its center, a radius, and then a color. Okay, so let's see if we can do that. Let's do draw circle. And then we just need the center X and Y coordinates. So let's do it like that. Have a radius of 20 for now, and then let's make it green. Whoops, green. Awesome. Okay, so that works. Some other things I want to try and do is I think that we can probably, instead of using these magic numbers here, we probably want to set some global variables for setting the screen width and height. I'm not sure the best practice for C++, but I'm just going to do it in like the C kind of way, which is where we define, I think we define like a constant height to be 800. Let's see if this works. Define width to be 800 as well. And then we can put that here and here. And let's see if this still compiles. That does not compile. So let me look up how to define macros in C. Maybe you don't need the equal sign. Yeah, let's try that. That doesn't seem to work still. Define. Seems like this is not best practice in C++, so I'm not actually sure how we do this. Maybe we can just, does this work if I just do it like this? Int height equals. Okay, that seemed to compile, but now our circle is at the bottom of the screen. Oh, that's because I want it at height divided by 2. Height divided by 2. Width divided by 2. Oh, not here. The position should be height divided by 2, and width should be divided by 2. Okay, so that seems to work still. All right, and then so what do we want to do when we have a particle rendered to the screen? We basically need to give it some properties, going back to like physics. And basically, in order to add particle motion, we are going to want to give this circle basically like an x and y that we can update over time. So every time this game loop, for every frame that's drawn, we can update the particle or the circle's position. So I think the way we want to do that is we can define a struct, and we'll call it particle. And this particle should have an x position. So it will be an integer x and an integer of y for its y position. And we can also have a velocity in both x and y directions. So we can call it vx and vy. Let's see. I think that might be all we need for now. And we can talk about adding acceleration later. But basically the logic should be for every frame, we have some velocity and we have some position. And every subsequent frame, we want to add the velocity to the last frame's position. So that would basically give us some movement over time. So let's see. So since we're defining a struct particle, we want to create a particle. I guess we can do it over here, and we'll probably want to refactor this later. But for now, we'll just dump everything into the main loop. So we'll say create a particle, and I will call I guess we want to make this capital. Particle. And then we can, I guess we can pass in an x and y position and a velocity. So we can give it, I don't know, we'll just say 200, 200. Let's put a velocity of 1 and 1 for now. So this creates a particle named particle. And then in our game loop, we are going to, let's see. We want to render this particle. So let me think about how we want to do that. Every time that we clear the background, we want to draw a circle with the particles. Yeah, so the particle's x position, particle.x, particle.y. This particle should also have a radius, so we can give it radius, and then pass in a radius here. So we'll make it size 20 again. So we want to pass in particle.radius. I guess we can say it should have a color. Well, for now, we'll just set the color in the main function. So what were the things we need to pass into draw circle? It was x, y, radius, and color. Okay. So that should, let's see if this compiles still. Need a semicolon here. All right, so that still works, and we're rendering the particle at 200, 200. And by the way, in computer graphics, the standard is for the x positive to be like from left to right, and for y positive direction to be from top to bottom. So it's kind of the y-axis is flipped from like traditional graph in mathematics. Okay, so now we have the particle rendering. We now need to, in our update loop, we want to update its position every time that a new frame is drawn. So let's see. I think that should happen here. Update loop. And then we'll call this our draw loop. So whenever we update a frame, we want to basically say particle.x. Is there a plus equals operator in C++? I'm not sure. We're gonna want to add its velocity. So yeah, let's say particle.vx, particle.y, particle.vy. And I think this should work if I'm not mistaken. So let's try and run this. Oh yeah, perfect. So now our particle is moving across the screen. And we'll see that once we get to the edge of the screen, nothing happens. It just goes off the screen because we haven't added collision yet. So before I do that, I think maybe this main function is getting a little bit too ugly. So I'm actually going to see if I can refactor this, and basically I want to create our update and draw loops outside of the main function so it doesn't get too big. So I think we would, let's see, we want our update loop to not return anything. And we can just move this over here. And we want to have a draw loop. And I think we can move this here. And then inside of our game loop, we will say update frame. So we'll call update. And then inside of our draw loop, we'll call draw. I wonder if this works still. Let's test that out. Does not work. So particle, okay. So I think we have a scoping error here. So we need to pass in to our update function our particles. So I think in this case we're going to this is probably terrible code, but I think we're going to need to pass in a particle reference, and then we need to pass it in here. So particle. See if that works. Still doesn't work. So particle is not declared in this scope. Why is that? Oh, same thing for our draw function. So this is probably not the best way to do it. Nope, that should go here. And then we need to pass in our particle here. All right, so that seems to work fine. I'll think about refactoring that later. I'll probably run it through Gemini and see if there's a better way to do that. But for now, what we have accomplished is now we have separate functions for our update and draw, and we can, I guess we can just think about those in a more compartmentalized way. All right, so now that we have this, I think we need to also basically check for collision if we want to make this particle bounce. So let me think about that. In our update loop, before we update the x and y, we're going to actually want to check to see if the particle is essentially colliding with one of the walls. And I think for this demonstration, we'll just say quite simply, if the particle's x position, and we're going to want to look at x plus the radius. So I'm not sure if let me open up a drawing and I'll draw this really quick. Okay, so basically this is our game window, and we have particles, or a particle with some x and y velocity. So the position is fixed here for the single frame, but it has a velocity, so every subsequent frame it will be moving in that direction that its velocity is pointing. But basically by the time that a particle gets here, and it has some radius, right? So it will have an x and y position here, and the velocity will still be pointing in this direction. But at this point, once it hits the wall, we want to detect that there's a boundary, like a wall, and we need to use, I guess, some math to figure out which way it should bounce. And I think that, let me think about this. I'm not sure. I think that if it hits one of the bottom walls, we basically just need to flip the y component of its velocity negative. So it will basically just reflect off in this direction. And if it hits a sidewall, we need to flip the x velocity. So it, if it was moving this way, it will just move the other way. I think that might work. We might get some, maybe that's not correct physically. So we'll see what that looks like, and I can adjust it later. But to detect when it's near a wall, I think we need to use its x and y. Since the x and y that we're defining is its center point, we actually want to look at x plus the radius, x and y plus the radius. Yeah, so let's try and code that out. So back up here in our update loop, we will say, we're going to want to say check for wall collision. And we'll basically have if statements, I think. So we'll say if particle x greater than or equal to the size of our window, so width. And I think in the negative direction, we also need to say if it's less than or equal to 0. Maybe I'll just flip this around because that looks better. So if our particle's x position is basically going out of the screen, I think the trick is we need to reset its x to be, oh, sorry. And we also want to check the x plus the radius. So particle dot radius. And then in this direction, it'll be plus minus radius. Particle x minus, oh, sorry. Particle x minus particle dot radius. What do we want to reset particle's position to be, let's see. Maybe this has to be separate if statements. So if it's going off of the screen, we need to set particle x to be equal to 0. 0 plus particle radius. And then I think else if particle x minus particle radius is great. So this is going off the right of the screen. We want to set it equal to basically the width minus particle dot radius. Okay, so hopefully that handles the x portion of collision. And we also wanted to reset the velocity. So we want to flip velocity. So particle dot vx, I guess we can say times equals -1. And then same thing here. And then we can copy and paste this for particle y. So let's change this to y, particle radius. I think we can just change all of these directly to y. And then we need to change this to be height. And if I didn't mess up, let's see what this looks like now. Maybe I can increase the speed, but we'll see what happens here. Oh, okay. So it did bounce, but it went off screen a little bit. Interesting. Okay, let's check out why that's not working right. So particle x plus particle radius less than or equal to 0. This should be minus particle radius, I think. This should be plus. And let's make the speed a little bit faster. So we can say, where did we set our velocity? Let's set it to 5. And let's run that again. Okay, it seems to be working. Let's change the angle of our thing to see if it works. Like, let's just make it go in the, make it go horizontally. Let's give it some vertical velocity as well. Wow, okay. That seems to work pretty well. Wonder what happens if we make it go faster. So let's do like 50 and 4. Seems to still hold up. Okay. Pretty awesome, guys. Let's see what else we can do. There's another. I wanted to check the FPS of our program, and I think there's probably a. I think it's called draw FPS. Yes. So let's use this draw FPS function to check how fast our program is running. Let's see. Maybe in our draw loop, we want to draw FPS. What is it? All caps. Draw FPS, and we'll give it a position of 0, 0, color white. Oh, you can't put in a color, so I'm not sure if the position will work like that. Let's see if we need to change the position. Okay. So it seems to be running at around 60 FPS. I'm not sure if it's capped. I think there's also a max FPS function somewhere. Set target FPS. I wonder where we maybe this happens outside of the main loop. So set target FPS. I wonder if we can increase the FPS past 60. Let's say 100 FPS. There's an error. So set target FPS says expected constructor, destructor, or type conversion. So why is that? Set target FPS into FPS. Maybe I have to run this in main actually. So let's do that here. I'm guessing it'll be after we create our window context. Okay, so it started out at around 100 FPS and it dropped down to 60. So maybe that's a limitation of my machine. But that's okay. I'm also running this in a virtual machine, by the way. So um, I'm not sure if that affects performance. Probably does. Okay, so that's pretty cool. I think we'll close the video for today. And next time we can talk about some refactoring and adding multiple particles and then figuring out possibly collision between those particles, which I think will be pretty tough. But yeah, thanks for watching and see you in the next video.